A-level EDEXCEL Math chapter number 5, exercise 5A. We are going to study about the gradient where we have equation of line y equal to mx plus c. We can find the gradient of a straight line as we are given this straight line in black color from point P to point Q, joining 2 points, then the vertical distance and the horizontal distance. We can find gradient as the gradient m of a line joining the point with coordinates x1 y1, as P1 has coordinate x1 y1 and Q has coordinate x2 y2. Then gradient can be calculated by formula. We write gradient equal to m, which is vertical distance y2 minus y1 over the horizontal distance x2 minus x1. Now we solve question. The line joining 3 minus 4 to minus e 2g as gradient equal to minus 3. Work out the value of g. Now we solve this. We are given points. Suppose say P point is equal x1, y1 and Q point x2, y2. Suppose P is equal 3 minus 4 and Q we are given minus g into 2g. At first we find the gradient. As we know, gradient equal to m y2 minus y1 over x2 minus x1. So we replace the value. Here y2 is 2g. As we can see, this is y2 equal to 2g and x2 minus g, y1 equal to 4 and x1 equal to 3. So we replace the value y2, which is 2g, minus y1, which is minus 4 over x2, which is minus g, minus x1 is 3. As we know, the line joining these 2 points has gradient minus 3. We are given m equal to minus 3, so we replace in place of minus equal to minus 3, and then we get 2g minus minus plus 4, as we can see minus minus plus 4 divided by minus g minus 3. Now we simplify it to find the value of g. Now if we write this, then by cross multiplication we get minus 3 into minus g minus 3 equal 2g plus 4. When we multiply we get 3g plus 3 into 3, 9 equal 2g plus 4. So we get 3g minus 2g and 4, 9 to the right side we get minus 9. So g is equal to minus 5. This is the solution of first. In this question we have to show A, B, C. These points are collinear. For collinear points we must know if the slope of point AB and AC lines will be equal, then we will say the points A, B, C are collinear points. Now we solve it. Given A point minus 2a into 5a and B point 0, 4a and the C point 6a into a. At first we find slope gradient m1, that is which is equal to, as gradient is y2 minus y1 x2 minus x1. Here we can see 4a is y2 minus from a 5a is y1. Now divided by, as we can see, x2 minus x1. Here 0 from b, this is x2 minus x1 is from a minus 2a, we will find m1 which is equal 4a minus 5a, we will get minus a divided by, we can see 0 minus into minus a, which will be minus minus plus 2a, then gradient equal to minus 1 by 2. Now we find second gradient which is m2, that is gradient of AC. We can see 6a into a. Here a is y2 and from a 5a is by 1. So we write a from c a minus from a we get 5a by 1 divided by x2 minus x1, that is here 6a is x2 minus x1 is minus 2a. So we write minus 2a and simplify it. A minus 5a we get minus 4a divided by 6a minus minus plus 2a. We get m2 equal, now we get minus 4a divided by, as we can see 6a plus 2a, which will be equal to 8a. That is m2 equal, when we cancel minus 4a by 8a, we will get minus 1 by 2a, minus 1 by 2. So we can see from equation 1, m1 equal minus 1 by 2 and m2 is equal minus 1 by 2. So from equation 1 and 2, we conclude because both the gradients are equal, so the points A, B and C are collinear. Exercise 5b, 11 question. The straight line L passes through point 06 and has gradient minus 2. Suppose mx plus c. This is the equation of the line. Then as the point is, we have 06 and gradient m we are given minus 2. So we apply the point y, m and x. In place of y, we will write 6 and in place of m, which is gradient, we will write 2. The value of x is 0 plus c. So we get the value of c is 6. We write equation of the first line, which will be y equal to minus 2x plus the value of c is 6. This is number 1. Now it intersects the line with equation, the second line having equation. This is say L1 and the second line we are given 5x minus 8y minus 15 equal 0. This is L2. We write it just like as y equal to mx plus 6c. Then we will write 8y equal to 5x minus 15. Then y will be 5x minus 15 of 8. So we get the equation of line y equal to 5 by 8x minus 15 by 8. This is the second equation of line, which is L2. Now, because both the lines intersect with each other at point P, so because they intersect, so we equate both the lines to get the value of x. So we write, as we have L1 first equation, y equal to minus 2x plus c, and the second y equal to 5 by 8x minus 15 by 8. We equate the equations to find the value of x. Minus 2x plus c, which is equal to 5 by 8x minus 15 by 8. Now multiply both sides by 8, we get 8 into minus 2x plus 6, 8 into 5x by 8 minus 15 by 8. We get minus 16x plus 8, 6, 48. This one 8 into 5x by 8 minus 8 into 15 by 8. We get minus 16x plus 48. On the right side we get 5x minus 15. We interchange values, minus 16x to the right side plus 16x and minus 15 to the right side we get plus 15. Here is 21x and this is 63. We get the value of x will be 63 divided by 21. We get x equal to 3. Now we use the value of x in equation 1 to find the y. So we use minus 2x plus 6 as we can see above. Y equal to minus 2x plus 6. In place of x, we write x equal to 3 equal to 6. Then y will be minus 6 plus 6. The value of y is 0. So the point P will be S. P here x is 3 and y 0. This is our answer. Straight line L1 with equation y equal to 3x minus 7. As we can see, this is the line y equal to 3x minus 7. Intersect the straight line L2 with equation ax plus 4y minus 17 equal to 0. And this is the L2 equation ax plus 4y minus 17 equal to 0. As both the line intersect at the point P, here P is minus 3 into B. This is the point P minus 3 into B. In the first part, we have to find the value of B. First of all, as the point P lies on the line, so we replace this value in place of x and y as we are given this line and the point is placed in this equation. In place of x we write minus 3 and in place of y we write minus the value of point B. Now 3 minus 3 into this is the value of B. In the second part we find the value of A. Now as the point is minus 3 into minus 16, as this point lies on the second line ax plus 4y minus 17 equal to 0, so we apply this point on this equation. In place of x we write minus 3 and in place of y we write minus 16, and now we simplify it. When we simplify it, we will find the value of A, which is minus 27. As a line P has gradient this and passes through the point, so equation of line with gradient M and point x1 y1 point will be, as we know, y minus y1 equal to M into x minus x1. We will use this equation to find the equation of line. So we put as gradient is 2, we have M equal to 2 by 3 and P x1 y1 equal 6 minus 12 as we can see here. So we replace the values of the point and slope. We get y minus, here y1 is minus 12 and slope M is 2 by 3, x minus, here x1 is equal to 6. So we will find the equation of line P, y minus minus plus 12 equal 2 by 3 into x minus 6. Now this 3 is multiplied on this side. 3 y plus 12 equal to 2 into x minus 6. Now we have 3 by 12, 3, 36 2x minus 12. Now we find the equation of line 3y, we write as 2x, we convert 3y plus 36 to the right side, we will write minus 3y minus 36, and the last one is minus 12 equal to 0. We will get 2x minus 3y minus 48, which is the equation of line P. Now, as the point A lies on the y-axis, so in equation of line we will replace x equal to 0. So substitute x equal to 0. 2 in place of that 0, minus 3y minus 48 equal to 0. We get minus 3y equal 48, and the value of y will be 48 by minus 3. We get y equal to minus 16. So the point A will be as x is 0 and y will be minus 16. This is the coordinate A. Now we find second equation of line Q. Now for the line Q, as the line Q has gradient minus 1 and passes through the point 5, 5. For line Q, gradient is minus 1 and the line Q has point which is 5, 5. So to find the line Q, we will use equation y minus y1 equal mx minus x1. Now we replace slope m and x1, y1 values. We get y minus, as y1 is 5 and the gradient m is minus 1 and x1 is 5. We find the line Q, y minus 5 equal minus x plus 5. Now x minus x to the left side will be positive, plus y minus 5 and this 5 will become negative. We get equation of line which is x plus y minus 10 equal 0. Now as the point Q lies on x-axis, so to find the coordinate B, we replace y equal to 0 in equation of line Q. This is the equation of line Q. Now replace y equal to 0. We get x plus 0 minus 10 equals 0. Then x will be 10. So the point P has coordinate x is 10 and y equal to 0. Now we have found the coordinates A and the B. So now we will find the gradient of AB line. Now suppose A x1 y1 which has coordinate, we can see 0 minus 16, and we say x2 y2 equal 10 0. Now we find the gradient of joining these point AB. We find now gradient, as we know, m equal to y2 minus y1 over x2 minus x1. We replace these values here. Y2 is 0 minus y1 is minus 16. Here x2 is 10 minus x1 is 0. We get 0 plus 16 over 10. So m will be 16 over 10 or 8 by 5. This is required gradient. The gradient of AB will be m equal to 8 over 5. Here in this question, we have two lines. The line y equal to x minus 5, the first one, and the second line y equal to 3x minus 30. This is the second one line as we have shown on the figure. This is the line y equal to x minus 5, first one, and the second, this is the line y equal to 3x minus 30, and the point of intersection of both the lines as intersect at the point S, say S. The point T has coordinates. Suppose this is the point T having coordinates minus 4 and 2. We have to find the equation of the line that passes through the points S and T. It means the point, this is the line which passes through S and T. We have to find the equation of the line ST. Now, as the point S lies on both the lines and is point of intersection, so we will equate equation 1 and 2 to find the value of x and y. First of all, we equate equation 1 and 2. By equating, we get x minus 5 equal to 3x minus 13. From here, we write 3x. We bring x to the right side, it will be minus x, and minus 5, we bring minus 13 to the left side, we get plus 30. The sign is changed. So 2x will be equal to 8, and then x will be 4. Now we replace the value of x in equation 1. For x equal to 4, in equation 1, we get value of y. Y equal to, in place of x, we will write 4 minus 5. Then the value of y will be minus 1. So coordinate of S point will be here x is 4 and y minus 1. Now when we have find the coordinate of S and we also have the coordinate of t are minus 4 and 2. To find the equation of the line ST, first of all, we have to find the slope gradient of ST. So the gradient will be m, we know y2 minus y1 over x2 minus x1. We replace the values. Here 2 y2 minus y1 is minus 1. We write here as, and then x2 minus 4 minus x1 is 4. So we get 2 plus 1 minus 4 minus 8. The answer would be minus 8. So we get gradient m equal to 3 by minus 8. Now we have to find the equation of line. So equation of line will be y minus y1 equal m into x minus x1. Now we have gradient m equal to minus 3 by 8 and the point S we use for minus 1. We write y minus, here y1 is minus 1 and we write gradient minus 3 by 8 into x minus x1. We can see in place of s4, we write here 4 and we simplify it. Y plus 1 equal minus 3 into x minus 4, and this 8 is multiplied by this side. We get 8y plus 8 equal minus 3x plus 12. Now we get 3x We bring 3x plus 12 to the left side. The signs will be changed. We get 3x minus 12 plus this one 8y plus 8 equal to 0. So we find 3x plus 8y minus 12 plus 4, the answer would be 4. So this is the required equation of line as G. Y equal to mx plus c. This is the required line. As the point minus 2, 7 lies on the required line. So we use this point in equation 2. In place of y, we write 7. Also, as both the lines 1 and 2 are parallel lines, so the slope of required line will be m equal to gradient of line. This is the gradient of required line. Now, we have gradient for required line and the point minus 2, 7. We use both things in equation 2. In place of y, we will write 7 and m as this is 4. In place of x, we will use minus 2, and by this way, we find the value of c, which is minus 8 plus c, then c will be 7 plus 8, which is 15. So, the required line will be y equal to m is 4, which is gradient, 4x plus c, 15 will be applied in second equation. 4x minus y plus 50 will be the required equation. Question 11. A line L1 has equation 5x plus 11y minus 7 equal to 0. Here is the given equation of line. And this line crosses the x-axis at A, as we can see. L1, this is the line, crosses this x-axis at the point A. And the line L2 is perpendicular to L1, as this is L2 second line which is perpendicular to L1. We can see that is having 90-degree angle between the two lines L1 and L2. First of all, we have to find the coordinate of the point A. So we find the coordinate of the point A. As the point A is on x-axis, so we put y equal to 0. So we get 5x plus 11 into y0 minus 7. We will get 5x plus 11 0 minus 7, that is 5x minus 7 equal to 0. We will find the value of x. This will be 7 and 5 will be divided by 7. So point A, which is on x-axis, having coordinate 7 over 5 into y0. This is the first part. Now we have to find second part. We are given find the equation of line L2. We have to find the equation of line L2 and we have to write the answer in the form ax plus by plus c. So we solve it. At first we write given line 5x plus 11y minus 7, 11y equal to minus 5x plus 7, and then y will be minus 5x plus 7 and divided by this 11. So we get y equal minus 5 over 11x plus 7 by 11. So the gradient of the given line, say m1, will be minus 5 by 11. Now to find the gradient of the line 2, as we know L2 is perpendicular to the line 1. So the gradient of L2 will be m2 equal minus 1 over m1, which is minus 1 over minus 5 over 11. Then gradient of the second line will be, when we reciprocate, we will get 11 by 5 and minus minus will be plus. Now we have the gradient of second line and the point A. Now we find the equation of second line. Use y minus y1 into mx minus x1. We have y1 is here 0 and the gradient of the line is 11 by 5 and x minus x1 will be 7 by 5. Now we simplify this and find equation of L2. Then y equal 11 into x minus 7 by 5 and this 5 which is divided here on the other side it will be multiplied by we will get 5 by into 11x minus 11 7 77 by 5. So when we multiply equations by 5 on both sides, we will get 5 into 5 by 5 into 11x minus 77 by 5. We get 25 by 55x minus 385 by 5. We get 25 by 55x minus 77. Now we will get second equation of line 55x minus 25 by minus 77 equal C. Exercise 5 question 7. Find an equation of the line that passes through the point. We have to find an equation of line as point 5 minus 5 and is perpendicular to the line y equal to 2 by 3x plus 5. As given line is y equal to 2x by 3 plus 5, we have to find required line. For this, as we are looking here, this is the given line y equal to 2x by 3 plus 5 and this is the perpendicular line which is the required line we have to find and a point lies on this point. Now we have to find the equation of perpendicular line. First of all, we have to find the gradient of the required line. Remember that for two perpendicular lines, product of two gradients is minus 1. That is m1, m2 equal to minus 1. In other words, m2 equal to minus 1 and this one is divided. By this way, we can find the gradient of perpendicular line. For this, as in this equation, when we compare by y equal to mx plus c, we can see this is the gradient. This is the gradient of given line. Suppose this is m1. Now to find the gradient of perpendicular line, we know the condition m1, m2 equal to minus 1. m1 is the gradient of the given line and m2 is the gradient of required line. To find the gradient of required line, we will write minus 1 over m1 and now we replace the value of m1 in place of m1. We write 2 by 3. So the gradient of required line will become minus 3 by 2. When we reciprocate this term, we get minus 3 by 2. Now, when we have found the gradient of required line and the point lies on the perpendicular line, which is 5 minus 5. As we can see, this is 5 minus 1. 5 is the point lies on the line. Now we will use it. Now we use y minus y1 equal mx minus x1. Now we use the point y minus y1 is minus 5. We will write here minus 5 and the slope is minus 3 by 2 into x minus x1 which is 5. Now we simplify this equation. We get y plus 5 and this 2 is multiplied on the other hand by equation y plus 5. Here we have minus 3 into x minus 5. Now we simplify it. 2y plus 2, 5, 10. This 2 is multiplied the both the terms inside the brackets. This is also multiplied inside brackets. We get minus 3x minus minus plus 15. So now we get minus 3x to the left side, 3x and plus 15 also to the left side, minus 15, and the two term 2y plus 10 equal to 0. 3x plus 2y minus 5 equal to 0. This is the required equation of perpendicular line. Exercise 3G question 7. A point P lies on the line with equation y equal to 4 minus 3x. As this is the line and here is the point lies on the line, say point xy. Point P is a distance 34 from the origin. As we can see, this point is from origin having distance equal to 34 square root. We have to find the two possible positions of the point. So first of all, we write given P xy, this is the point, and O origin having coordinates 0, 0. Now as the distance is 34, using distance formula, now as D is 34 square root and we will write square. Now we replace values. X1 is 0, as origin having coordinates 0, 0. We will write in place of x1 and y1. We get y minus 0 square. So square will be cancelled with the square root. We will get 34 equal to x square plus y square. This is the second one equation. Now we have to find the values of x and y. For this, we will use both equation y equal to 4 minus 3x and 34 equal to x square plus y square. From equation 1, we will apply y equal to 4 minus 3x in the second equation. So we will get 34 equal x square plus in place of y, we will write 4 minus 3x square. Now we will simplify it. We get 34 here x square plus 16 square plus 3x square. We get 9x square minus 24x. The square of 4 minus 3x will be 16 plus 9x square minus 24x. Now we solve it. 1x square and 9x square equal to 10x square minus 24x plus this one 16. Now we get 10x square minus 24x plus 16 minus 34 equal 0. 10x square minus 24x. When we subtract 34 and 16, we will get minus 18 equal to 0. Now we will factorize this equation to find the values of x. This straight line L1 passes through the point minus 4, 14 and has gradient minus 1, 4. This is the straight line L1. This line has point, a given point, minus 4, 14, and the slope and the gradient is minus 1 by 4. So we use y2 minus y1 into m x minus x. Now apply the values of the point and gradient. Y minus, as y1 is 14, we write, and the gradient is minus 1 by 4. X minus x1, we can see the point minus 4. Now we simplify it. We have y minus 14 equal minus 1. This 4 is dividing here. We bring this side. It will be multiplied by these two terms. Here we get minus minus plus 4. Now we simplify it. 4y minus 56 equal minus x minus 4. Now x plus 4 plus 4y minus 56. We convert these two terms to the left side and these sign will be changed. We get x plus 4y minus 52 equal to 0. This is the equation of required time. For the part B, we have to write the coordinates of point A. This point A lies on the line L1 which crosses the y-axis. As the point crosses the y-axis, so we will put y equal to 0 in equation. X plus 4y minus 52 equal to 0. This is the equation of line. Here we replace y0. X plus 4 into y0 minus 52 equal to 0. From here we will get x minus 52 equal to 0. So we get x equal to 52. So the coordinate of the point A will be